So we're gonna launch into another session from the course. This is in the course itself. This is the third session of the course. So there's an introductory session, the nature of science session, and then we go into a session called teaching and learning. And I don't know if we told you, in Berkeley, our course meets once a week on Fridays, and it's 3 hours? 3 hours long once a week. So our sessions are long. And if you're in a, if you're teaching a Tuesday, Thursday course or something like that, you would break up a session maybe into 2 meetings. So we use this, a term, a session, to relate to a block of instruction that we're doing that fits into 3 hours for us once a week. And we like having longer blocks of time rather than many shorter ones for this, but that's not a pedagogical issue, it's our preference, and you might have a different preference. Okay, so this session is about teaching and learning. Again, the students have some homework. They've read a paper about teaching and learning, and we asked them to come into the class and do a quick write, to write their thoughts about and reflect on the paper that they read, and to share how they think these characteristics of teaching and learning might relate to their own work working with visitors in the museum. We're also, in the COSEE course, able to take them right onto the floor of the museum, and they're able to observe some visitors in the museum with educators and make some observations and gather their impressions of teaching and learning in that context. For our purposes right now, I'm going to give you a prompt that I want you to respond to, and we're going to have you respond individually first, again, like we were doing before lunch. I'll give you the prompt, just think for a minute, and then I would like you to take out a pencil and paper and write or draw or make some record of your thoughts and responses to the prompt, okay? So the prompt is, what are your beliefs? What are your beliefs about how people learn? And how do those beliefs influence the way that you teach? Or in the case of your students, the way you will teach in the future. But what are your beliefs about how people learn best, and how does that influence your teaching? So finish up your last thought. And what I'd like you to do next is, for about half the people in the room, half the people at each table, to stand up and go find a partner at a different table. So sit down with a new partner that you haven't talked with today and talk a little bit about some of the things that you were thinking about and recording. So tell me, again, a few of the things that you were talking about with your partners about your beliefs related to teaching and learning and how that influences your teaching. Yeah, Kim.
My group was talking about how students can really lock into whatever it is that you're teaching when you show the relevance to their own lives. So when it becomes a little bit more personally engaging and they can see how it relates to them, then it makes it easier to either kind of spark interest in that subject or foster what's already a pre-existing interest.
Okay, good. Relevance to their own lives, previous experiences, connections, relationships. Yeah?
I really liked what Franny said to me. She said she likes to accommodate different learning styles, so not just teaching with one particular style, so dealing with the visual learners, dealing with the kids that need more hands-on learning, or appealing to different learning styles to try and target every different type, and that was really good.
I really like everything Franny tells me. But okay, so this is a natural thing that teachers, instructors can fall into, is teaching the way that I learn best, right? And Franny's saying, I'm not the only learning style in the world. There are a variety of different styles for different people, and I have to be shifting gears and moving out of my comfort zone as a teacher in order to make my learners more comfortable. Okay, anything else? Any other ideas? Yeah, Mark?
Go ahead.
No, you got it first.
Oh.
You earlier.
Well, it just kind of builds on that, but the idea that as a teacher, not just varying the approach for learning styles, but varying your own style can be really effective. So going from a very humorous, demonstrative way of teaching to a very quiet, serious way with the same group of people can sometimes help keep people engaged. And we're talking about that kind of variations in pace and volume and complexity from simple to complex and all those things as well to keep people waiting for what comes next.
Yeah. Great, nice. Did you have something different, Mark?
A little different, just that it goes with that social context again. When I see something new that's been sort of devised by people that are younger than me, I pick it up because I figure I don't really understand, but probably they do. So looking at what different generations have felt comfortable with in terms of their teaching and learning is good too, because then you can touch on that and you can learn from that. That comes back to what you're saying, putting yourself in the discomfort zone a little bit, keeping open, trying new things.
Yeah.
It's all G.
What's that?
It's all G.
It's all G?
Yeah, that's something I'm picking up from the younger generation.
Okay. Yeah.
So, I learned about the 7 multiple intelligences when I was learning teaching pedagogy, and so I try to address those different ways of learning and teach. Just try to hit the same topic or same concept a number of different ways to try to get somebody to get it in the group.
Yeah. Okay.
I think everybody in our group kind of did that too.
All right. Yeah.
He shared something really good about the bonding that takes place with the students when you take them on a field or outdoor kind of activity. That sometimes you need to pace when you have that activity so it doesn't come overly social sometimes, that they're still focusing and learning something from it.
Right. So there's something that's not related to pedagogy necessarily that's about the community, about bonding, about having a sense of community in the classroom, a community of learners that trust each other, et cetera, and then being a little bit careful that that doesn't cross over into something that's purely social and no longer academic or learning or whatever. So anybody have thoughts about that, about the, I always try and get my son to distinguish between the teachers that he likes and the teachers that he thinks are good teachers, and to understand the difference and if they're the same or different. And so do you have thoughts about the fun teacher, the teacher that makes the environment really great versus?
Kind of related to that, Leigh was talking about how she really believes in experiential education, and I do too. It's what we do, and she even tries to make it fun. I try to make it fun, and she even tries to trick her students into learning. They don't think they're learning along the way, and then in the end, she gives them well, see, you did learn, and it was fun. So I think enthusiasm is a big part of that as well. It rubs off onto the students and makes them more open to learning.
Yeah, the surprise of learning, the playfulness of it, yeah.
I like to try to also incorporate students teaching to show them what they have learned and what they are not so sure about still, because once you try to explain it to somebody else, it becomes very clear quickly what you need to still kind of work on.
Yeah.
I was going to say social environment. There was a study done quite a while ago that says when you take kids out in the wild, you guys mostly all know this probably, that they are worried about sort of where they are in the pack because they're in a new environment, so they will do some of that pushing and nudging, and so just build it in. Instead of assuming you're going to get them to focus right away, build that part in, look for what is natural for us and go with it. And then your comment as a parent, I got to say, my kids know that their job, so to speak, or their the reason that they're in an educational situation is to get the information, to get the training, and to show that respect to the older people, which is a very antique method. But they pull twice as much information as most of the other students because they know that that's what basically they're there for. That's a different thing, you know. I'm not sure, as a teacher, it's hard for us to deal with that, but we are dealing more and more with parents now, and parents want their kids to do well, and this goes across a lot of cultures. So this is this maybe brings in something we should be thinking about. How do you talk to? I'm a strong believer in multi-generational teaching. I think you do so much better when you get the whole family there.
Okay, so to the point of teaching by helping your students to teach each other also, and to be in this environment where they know that their job is there to be there to learn. That's one of the things that we're trying to model with some of these strategies that Catherine and I are using, is that, you know, I could have just given you another 10 or 15 minute PowerPoint about teaching and learning theory, but really the group already knows just about everything that I would have presented, right? I mean, you already know that stuff. Maybe not any one individual has everything in their head that I might have presented, but collectively you have way more in your heads than I would have presented. And you're giving a much more rounded description of teaching and learning with many more viewpoints than I would have been able to do in a short presentation. So you're way better at it collectively, and maybe even probably individually than any one teacher would be standing up in front. Okay, so where we're going to go from here, with this discussion as sort of the backdrop, we're going to have a variety of learning experiences. You're going to be the learner, and you're going to go through 4 different learning stations that all relate to similar content, but with different approaches. And your job is, you're going to be in a small group, probably about 3 people to a group, and you're going to rotate through 4 different stations. And I'd like you to, and the stations are self-explanatory. There's going to be materials and some very simple directions at the table that we'll pull up and put on the tables with you. And you just sort of go to the station and do it. And we'll give you, I don't know, 5-7 minutes at each station. We'll call time and ask you to rotate to the next station. As you're going through the stations, we'd like you to do the activity and really dive into the content, but also to be aware of yourself as a learner at each of the different stations. And really think about, how am I responding to this experience? Does this feel okay to me? Am I nervous right now? Am I like totally fine? Is this my comfort zone, out of my comfort zone, etc.? Just be aware of yourself as a learner at each station. And I have to sort of, full disclosure, this session is about teaching and learning, but it's partly teaching and learning about teaching and learning, and partly teaching and learning about content, about science concepts. Okay? And there's a little bit mixed together. But most of all, I really want you to think about teaching and learning, about yourself as a learner and how that influences you. But you can't do it without learning something, right? So the content has to be there. And so you have to really get distracted by the concepts themselves at the same time. Okay?
Drooling whatever on the cup makes it hard. It's hard to tell.
I know, it's all twisted. I don't know, that looks a little brighter. This does, to me. Wait, go ahead. This one has a little, refraction. This is refracting. It should look more bent.
Oh, it's hard with this cup.
Yeah, it's not working. Okay. Actually, that looks straight to me, but maybe it's the angle.
So we could try and float different objects to see which one would make it sink versus float, like we did with the first experience. So is this the money now?
And actually, we should be able to do that with this. So I think the A is the
sink?
So me too. It looks like it's refracting light. That's why.
Well, they both sink.
Okay.
So that ain't it.
How about the plastic? Plastic should float.
Well, chalk.
Oh, but plastic floats in fresh water too.
Yeah. Chalk maybe.
No, but over there, right? the plastic floated in one and not the other, the first one.
Oh, right, that's
Right?
true.
The plastic floated in the fresh, but not, no, it's floated in the salt, but not fresh.
No, it's hard to say because, well, maybe can we break it?
Okay, so everybody's gone through all 4 experiences now, right? We've rotated through all 4 activities. So now, just take a second, pause for a second, and review in your head the 4 stations that you went through. There was an open-ended investigation, station A, where you got a bunch of stuff, and it says, use the stuff here to learn as much as you can about the properties of water, warmer, cooler, fresher, saltier. Station B was a structured activity with a series of steps that you went through. You did an experiment, you set up some conditions and watched what happened. Station C was the problem-solving challenge. You got 2 mystery waters, figure out which one's fresh and which one's salt. And then the Station D was the read and answer, right? Straight content, read this, tell us what you read. Okay, so think about yourself as a learner, your own experience going through those stations. Which one did you like the best? Which one was the best learning experience for you?
Those are 2 different questions.
Well, okay. All right, so you can answer either question. You can answer either question. And if they're the same, tell us that. And if they're different, you can tell us that too. But which one did you like the best? And what about it was good for you?
Sure. B. What? First it was B.
So this group over here says, are all 4 of you in agreement? You're all
Which one did we
saying
like
B?
the best? We like
So you all like Station B, which was
we
the
learned
structured
that.
activity. So tell us, like, what was it about Station B that worked for you?
It didn't give us all the answers, but it gave us provided enough information where we could start to make our own conclusions. And it actually helped us with Station C. It helped us figure out Station C by learning what we did at Station B.
And it was almost a repeat of Station A. So it was like repeating experiment.
Okay, so the repetition was helpful to you. So they said you started at Station A, and you had that experience. Station B was like another chance at it, but more structured. And that helped you to solve the challenge in Station C. So that was a very satisfying learning experience for you.
Yeah, Station A wasn't very satisfying.
Station? Yeah. Okay, we'll get there. We'll hold that. We'll come back to that. So anybody else? Anybody else have a feeling about which one did you like the best? Or yeah.
Yeah, we like Station A.
Okay. The open-ended investigation.
I guess so, yeah. I don't know. I didn't think of it that way, but we just all seem to like Station A. Maybe it was our first one, though. Was that their first one?
Yeah.
Yeah, that's what I
You ended up at D?
Yeah. Was B their first one?
No, A was their first one.
Oh, okay.
So you guys liked Station A, the open-ended, and what was it about it?
I just thought it was really interesting. It was kind of demanding, and we had to really think, because then after that, then we already knew what was going on. We just basically went through the motions,
So you liked
using the information that we already learned.
Okay, so you liked starting off with a challenge that really made you think about it and figure it out. It wasn't sort of handed to you. You had to kind of struggle and work through.
Yeah, it was really interesting.
So it was exciting when we got it.
Yeah, we were excited when we figured it out.
Okay, great. Okay, anybody else? Any other impressions or personal reflections on your learning experience about which one was the best for you?
Our table enjoyed Station B.
So we have like whole table consensus in all these groups.
No, we don't.
Okay, all right, okay. So the first
that side over there,
it's just
they're
this
really strange over there. We went over there earlier, and it wasn't feel right.
Okay, so Kate, tell us about you guys. The 3 of you all agreed that you like Station B the best?
Well, we're worried that as as a student, they could get really frustrated at these other stations if they don't have the background knowledge. And I wonder if the reason why people here might say that they really enjoy that because they already have knowledge of density and circulation, and so they can use what they know and would have a lot of fun with it. But from a student's perspective, I didn't have any background. I think I'd get really frustrated.
Yeah, and I think the other thing was we did have, I think I'd like to say we had early success at Station C, and that was good because we kept saying, well, if we didn't, it would actually be a little frustrating, and would that have kind of killed it for the rest of the time until we tried? Would we have continued at with the same enthusiasm of investigation?
So this table has a really different view than you all did. That they liked the structured activity and having a success that they could build on. And they thought that for many learners that do not have a lot of prior knowledge or experience, the open-ended might have been frustrating. Rather than being a challenge that you love, they thought, oh, it's a little scary. It's like kind of putting me off. I don't know if I can be successful here. And
nobody else in our group, we pulled our group over here, they all agreed. They all like B too, it's just us.
Just you, the outlier? Okay.
Multiple intelligence.
Okay. Anybody else have a favorite station or one that worked with you? You guys said you didn't agree. What was happening?
We didn't actually discuss it, but I mean, I'm a repetition kind of person. Like, it's kind of like if you took a kid that knew nothing about construction, gave them hammer nails and some stuff, and said, "Here, play with this." They wouldn't necessarily figure out what to do with it. If you told them what those things were, they'd more likely have some fun trying to create something. And what you've got here are various different pieces that together make a really nice whole. But individually, it probably does matter what your learning style is and where you start in the sequence. But you would never just do one of these, I don't think, without some sort of other background or something like that. So it's kind of cool, you know? If I had my way, I would do all 4 of these with the class in some sort of iteration like that, and that would be fun.
Yeah. Okay, so
I don't know about these guys.
Yeah. Okay.
Right. I'd say so.
Well, I mean, how much experience a learner brings to it makes a difference in how their experiences of each type of table. So, like, where there was a table, one over here where I was lagging behind a little bit, right? With the questions and the slamming and whatever table that is over there, right?
Read and answer, yeah.
Yeah, read and answer. Like, I didn't have much to contribute to the group. I mean, I could have gotten there, I think, but you were going a little fast for me, you know? But at the more open-ended activities, we were all contributing, we were equal, you know, creating some things. So
Okay, so this is interesting again, like different kind of views. Some people felt like the open-ended was really challenging and you needed to have a lot of prior knowledge and experience to be successful at it. Linda's saying, well, kind of level playing field. We were all kind of like starting from scratch, figuring it out as we went along.
Yeah.
So, and then I heard Mark saying that, well, maybe the sequence makes a difference. Maybe it's not the activity, maybe it's the order that you do them in. Does anybody else have any thoughts about what order you did them in, or you wished you did them in, or you might do them in if you had kids, or, you know, in a classroom?
B had a clear question that it started with. And for some, I think that's the starting point. I won't say it's that way for everyone. And it may not be constructivist, but I think for some that helps. I know several teacher types in the room here that don't get very nervous if they don't know why they're in the room. You know, what's the purpose of why we're here?
And how long it'll take and where are you going?
Yeah.
Okay, so it was sort of comforting to have the structure of B.
And what you're going to end up with. And
Yeah.
is everybody going to end up there at the same time?
Yeah. So you're suggesting that B would be a good place to start? Is that
Or
what
at least some students.
For some students, B would be, having the structure initially would be a good place to start. Anybody else have thoughts about an optimal sequence?
I think for me, you know, the social interaction with the group members also kind of impacted the activity substantially. So it wasn't just the materials, it was the interaction that we went through. And so on some of them, the interaction was really positive. We worked together. And other ones, they wouldn't let me look over their shoulder. On this one, I was like, come on.
I would assume that too, this would be a very different experience, or at least A would have been a very different experience if it was just me by myself, or with a group that I wasn't able to necessarily work with as well, compared to being with a group that I could work well together. So having the structure would help in different circumstances.
So the social dynamics are important. If you're alone, if you're learning as alone, as an individual, that you structure the experience differently than if you were in a group and you're collaborating. Yes.
I think somebody said that too about looking at it as an educator. If you have an educator and science people in their group, and how you want to go at it, because us three, we really love the experiment part of it, the what if. We really got into the fun of destroying all things, doing all the different stuff together and writing and trying to figure out, which is why we like A. And I think because we were alike in that kind of way, we could keep it going, compared to if you had people who didn't enjoy that as much.
Okay, so intrinsic motivation. If you're motivated when you come into the room, you might be ready for a different kind of a learning experience than somebody who has to be sold on being a learner. Yes.
We started in Station D, and it was kind of interesting because as soon as you picked up the paper, I was already like, because I knew for me it was a time thing. Am I going to have enough time to read this thing through for all the content contained within, and get it 100%? But I kind of like starting there because it set the tone, and even though I didn't get everything out of it 100%, it was like I could use that foundation for when we were tinkering in the other stations. But definitely, I don't know, I really didn't like this station at all because I felt like it was another time thing. If I was given ample amount of time, I may have been able to work things out. But I felt like we didn't even get through fresh water, and we were stuck on fresh water. And I felt
we didn't have very much time there.
Yeah, it was weird. And then I also felt myself kind of like retreating, and I didn't say anything, and I was kind of just watching.
She was stressed out.
Okay, you guys are doing something weird and it's not working, so I don't know about this. But yeah.
Okay.
And then we got here.
Yeah, these two are cool.
So you started at D, and you said you were a little bit stressed out about it, the time thing, but you're glad you started there, that was a comfortable place to start?
Everybody was talking around me, and it's super distracting. Like, I'm the type of person, like, you have to turn off the radio. Nobody else can be in the room. Complete silence for me to be able to read.
Right.
That's probably why I don't read very much.
Okay. All right. Okay. What were other people's experience of Station D? The read and answer. Yes.
The moment I saw what we had, oh no, we're just going to read and answer questions. That's the most boring kind of activity for me.
Okay, so it was off-putting to you.
Yeah,
oh.
Initially.
Okay.
Right away. And then I agree with you, Eli, that it's kind of a nice place to start for background, but it's not very exciting.
It's like medicine?
Yeah.
You knew it was good for you, but it's like, couldn't quite. Yeah.
I would choose to do D last because you get the background sort of hands-on. You get to see the topic and actually figure it out yourself, and then going and reading the question and answer form, you have that hands-on experience that you can bring to that and understand it a little bit more in depth, I think. I would prefer to do D last.
Okay. Anybody else feel that way? We have a D first and a D last.
I think I'd go D, B, C, E.
Wait. D. So read and answer first.
Read and answer first, because then you get the background information to read.
And then the structured activity.
Structured activity.
So you read about it, then you prove it to yourself that it's true, and then what?
And then you get quick success. You're feeling confident about yourself, and then you go there and
do the open-ended.
And you got the open-ended, you get to figure it out.
Okay, all right. Now there were a bunch of hands that went up when I said, what about D? Yeah.
We did A, B, C, D, and it would have been really nice to have a chance to go back to A, because we read about, you know, flow of water, some things we didn't really, we were not looking for in the experiments.
I'm sorry, but we have a really crowded curriculum and there's a lot of standards to cover. Go ahead. I'm sorry, I'm kidding. Go ahead.
And did everybody really read?
Okay. Yeah.
I think it would be good if you read the D one first, but didn't have to answer the questions till the very end. You know, and then you could do all the experiments and then answer the questions.
I changed my answer.
Did I say that?
No, but I
Okay, so the reading the content first, fine, just don't make me answer it first. Let me have all the complete experiences before I'm accountable for this, for responding. Second. Yeah.
Dee brought out an interesting dynamic with our group. We had the different learning styles. We wanted to get to work and finish it and accomplish the goal. And this one did not want to do that at all. He's like, this isn't going to be collected. It's not going to be graded. Why are you guys even doing this? You're trying to distract us. We're trying to
Well, you know, it goes for assessment. In education, we usually have some assessment thing, right? We're going to have the end of the workshop checklist. That's your assessment. We're going to collect this one. I was like, not going to collect it.
Okay, turn in your papers.
Okay, which station was your least favorite? The one that either made you the most anxious, or that you felt the less successful, or for some reason was the one that you...
I like D the most.
You like D the most?
Because I could pick on E leg because you're stressing out.
The first one was the most stressful to me just because I didn't know how stupid I wanted to look in front of my group.
Okay, so first is hard, no matter what you're saying.
Yeah,
because
I know.
kind of working out your place in the group and.
And we want to know the correct answer to that one.
Okay.
All of the above.
So but I heard a lot of D's coming up. A lot of people saying D was their least favorite. And why? Say anybody want to volunteer? What was Hile said that she felt stressed out by the time pressure.
It wasn't my least favorite though. It just
Okay.
there was certain aspects of it that didn't like.
Somebody said SATs in our group. It felt like SATs.
Felt like you were taking the SAT?
Oh God, oh boy.
Yeah, I know this feeling, not good. Yes?
It's kind of the traditional reading, right? You know, you read it, you put it, but even though you had all the information, you know, like I said, I'm more into the discovery and having fun with all the experiment part, and at the end, even though you have to do that, that's like the least daunting part.
Yeah. Okay.
One other thing came up in our group that I thought was really interesting. When we got to station B, I guess it was, people started building on the knowledge we were starting to gain by sharing stories, and so I think some sort of a making it relevant lecture. Why are you laughing? Oh yeah. So, oh yeah, we were talking about, you know, how making ice cream in our families, or the fish was your story about with the salt, and then the brine and the fish, and anyway, it was really great. That was my favorite part, and that was actually our favorite station.
It's kind of like teachers refer to aha moments a lot. That could have, I mean, that was kind of like our aha moment where we were like, oh yeah. We were comparing it to, oh yeah, see, we do this all the time anyway.
And when did you have that aha moment? At Station B?
Mm-hmm.
Station B was what sort of brought up connections to your real life?
Because somehow we felt when we were at that one station, that I mean, maybe they weren't very exactly the same, and we just felt that when we were at that one D, it felt like it was really short, And other stations we felt was a little bit longer amount of time, which gives us time to interact a little.
Yeah. Okay, so it felt shorter. They were all about the same. Actually, I think I gave you more time at the very first station. It always takes a little bit longer just to figure out what you're doing. But other than that, they were all about the same length of time, within within 1 minute or something. Yeah. Okay, any other thoughts about the experience, about your experience as a learner? I heard first of all, a lot of different views about how you would use these learning experiences, how you would sequence them, which ones you were most comfortable with, which ones you were least comfortable with.
I learned that I was denser than any of this water.
You were.
So there are some sort of generalizable characteristics of each of these types of activities. The open-ended exploration, Station A, it's often used as a way to introduce a new subject, letting kids mess around with things, and helping learners to generate their own questions. Now, these are all generalizations, so individual people, of course, we'd already heard, responded differently. But it's a way to generate interest and foster a positive attitude with science, just sort of getting in there and, again, messing around. Encouraging learners to work together, develop and identify concepts, and provide a common base of experiences. So that's an important issue. Again, creating an experience that we've all had in common that we can build on from there forward. The structured activity is a good way to introduce concepts and vocabulary and processes and skills. This is the way you do science. This is follow the directions. They're structured, it's repeatable, it's testable, etc. You're guiding learners toward a discovery. The teacher knows what's going to happen, right? It happens the same way every time. And you're guiding your students toward that discovery. Again, providing a common base of experience and providing success. If you follow the directions, I know you'll be successful. This will work and you'll have an okay experience getting the predictable result that many other people have gotten. The problem-solving challenge, this is really a way of modeling what scientists do, right? You got a problem, you're trying to figure it out, let's think up a way to answer a question. It might provide a sense of accomplishment. It alternatively might provide a sense of frustration. It may challenge your conceptual understanding and your skills. That you think you understand this, and you may find out very quickly that you didn't quite understand it, or that you don't have the process skills to design an experiment. And it may develop a deeper and broader understanding by having a real-world application. You're actually able to solve this problem. And then, finally, the read and answer. This is a way to deliver content, right? This is what you need to know. You need to read this, and it'll help you in the other parts of this course, other parts of your life, whatever it is, but here it is, learn it. It may extend the information from a hands-on activity into another setting, which may not be possible to observe in the classroom. So this sort of read and answer stuff is really good for abstract information that's not observable in the classroom, that you can't get at through a hands-on activity. You just gotta read about it or have somebody tell you about it. And it might provide alternative explanations and make connections into other subject areas. But it's really delivering. It's not the same kind of interactive constructivist experience. Okay, so those are some of the characteristics of those stations as learning experiences. We're going to return to that in a few minutes. But in this session in the course, the students taking the course have been messing around with water and density and temperature and salinity. And we kind of leave them hanging at the end of the 4 stations, right? Just like you are now. And so at this point in the session, we provide them with some content related to density and currents. And we try and do it in as pedagogically sound way as we can that fits into the framework I'm going to share with you in a few minutes. But Catherine's going to take it from here for a few minutes and show you how we introduce some of the concepts behind the stations that you just went through.
And then later we'll even give you the answer to the mystery that the students do or that you can do as demos. So what we have around here now are 3 separate demos that our people volunteered to do for us. No volunteer. So what they're doing here, and they're about a little bit different pieces of the current puzzle. So what we'll do is, I don't think they know exactly when they're going to go on because I don't know which one's first either, but I think you guys are first. You guys, are you doing it by yourself?
Well, I've got plenty of wind, yeah.
All right, here comes Okay, so the first is have you ever felt the power of the water? So the students talk a little bit about currents and waves and maybe the difference between the two a little bit. And then a little bit about just what currents are. Move huge amounts of water, great distances in the ocean. How does that happen? Why does that happen? The ocean in motion. And one of the first things that happens then is a demo of the surface circulation of the water. So students can see a little bit about how does that take place, and especially when they've seen a map of the world and they see that in the northern hemisphere something is happening and in the southern hemisphere something entirely different is happening. So how does that all take place? And Dan has a demo here. You want to explain?
Can you see the outline? It's hard to see because we're trying to focus at 2 different depths here. A shallow or a pan might work a little bit better. See, there's North America over here, Asia and Australia. Okay, so we're looking at the Pacific Basin. And there are, you know what our main, anybody not from here? We're all from here. We all know what winds we live in, right?
No.
Northeast trades.
Thank you. And what's the ones just the other side of the equator?
Southeast trades.
Okay.
So what are you doing now?
I'm doing both.
What if you're in the worst latitude?
Well, then I just do this. All right.
Cool.
The idea?
So, good job, good job. So the students talk about what they see, and we put up the map of the actual currents up there, and they can see that much like Dan's hot air, what happens is clockwise in the northern hemisphere and counterclockwise in the southern hemisphere. Okay, so that's one of the demos. And one of the reasons we do this is not only to help the students with the content, but also so they can see the kinds of activities that they might use with the public to try to describe certain pieces of concepts. So this is kind of widens their ideas of the kinds of things, the simple materials they might use to do something like that. Okay, so next is what causes the vertical movement of water in the 3D ocean? Is a demo of estuary circulation. Do you guys have estuaries around here? Florida. Florida? Oh, sort of. Where am I? I thought I could be white. Okay, so this one is a demo of that. So take it away.
I'll take this away. Okay. So this is dense seawater, essentially. So it's in the other bottle we have just fresh water. And so we're going to try and screw that onto here without making a mess, and then turn it sideways so you can observe the mixing.
Here we go.
Out of pressure.
Right. Oh, the hardest part.
Yeah. And then if you guys come over here, you can observe it on the white background. Just put it down. Yeah.
Really cool.
Yeah.
Slow.
The blue is stuck over there. It's not. Oh, there it is.
If you're down at eye level with the bottles, you can see it when she's
Oh,
here.
yeah.
Oh,
actually, yeah.
Oh, I'm sorry.
So now that we know
Yeah, that's true. That's true.
I wonder if that's reflection.
Salt and fresh.
Salt and fresh. Salt and
But one
fresh.
has salt water, so it's more dense.
Yeah.
But same temperature?
Yes.
So, yeah, so this is just like a river and meeting the ocean.
Or going swimming after the rain.
Oh. Our students ask too, they're like, well, how long will it stay like that? And what will happen in the blue bottle? What do you think will happen in the blue bottle?
You change the white water be on top.
White water will be on, clear water will be on top. So we let that run for a second. So we have the chance to look at salty and fresh and hot and cold fresh over here too to see the differences. Okay, thank you. Okay, so now, have you ever seen The Day After Tomorrow? Was that the name of it? The one with, is that with the iceberg melting in the North Pacific? Yeah. Okay, most of the students have seen that one too. And this is melting of ice around the North Atlantic, is adding lots of fresh water. How will this impact ocean circulation and climate? So the students talk about this a little bit based on the information and the activities that they just did with the ice cubes and these kinds of activities as well, to come up with their prediction about what might happen. After that discussion, then we actually distribute the mystery water handout, which is the answer to the structured activity B. Why did the ice cubes melt faster in fresh water than in salt water? So a lot of you out there could probably describe it better than I can here. Would anybody like to describe it to all of us colleagues in the room? Anybody want to? What was going on with that? Why did it melt faster in the fresh water? We have Jeff here saying it's lower specific heat. So, Jeff, in English, what does that mean?
Fewer calories per cubic centimeter of water to raise 1 degree.
So tell me, am I pressing him too hard? No. So how does that, what does that mean to salt water and fresh water? And ice cubes?
All kinds of stuff.
Somebody like to help Jeff out over here?
Increase mixing in the fresh water.
Oh, how would that happen? Increase mixing.
Because you're melting a freshwater ice cube and fresh water, you're creating a temperature difference, so you get more mixing. And just as if you mix a cup with ice, the ice will melt faster than if you just let it sit.
And why is it that the ice cube in the salt water, when it's melting too, why does that not mix?
Because, well, that's the one thing we were thinking about, is that the difference in salinity actually overcame the difference in temperature, or it had a stronger effect than temperature. So the fresh water, even though it was colder, stayed on top, and the salt water was denser, so it stayed on the bottom. But it didn't promote the mixing.
Okay. So for those of you who are more visual learners, thank you all. That was really nice explanations. Here's actually a handout.
Most of this session, we were really focusing on teaching and learning, and learning styles and teaching approaches that were represented, sort of embodied in those 4 different stations. And we sort of left off with reflecting on your learning experiences, the potential that different people have different learning styles and preferred different things at different times in their experience, and that there might be a variety of different ways to sequence those activities. Then we took a little bit of a detour into the content, so you could really finish your own adult learning about density, salinity, temperature, and the relationship of those 3 things. So now we're going to return back to the teaching and learning part and think a little bit about the whole experience of this session. And it turns out that while there are a lot of different learning styles and different ways that you could organize and sequence these activities, there's been some research about it and some research into how people learn. And there's some generalized lessons that we can derive from that. Of course, not that there's a script or a formula that works for all learners all the time. But I want to share with you a little bit about what some of the research is related to how people learn. Some of this was conducted by a guy named Robert Karplus, who did his work at Lawrence Hall of Science when I was like in 3rd grade. And he was a physicist on the Berkeley campus, and a well-regarded physicist, a very successful research scientist. And he had kids that were in the local elementary schools. They lived 3 doors down from me when I was a kid. His family and my family grew up near each other. And we all went to the same school together. And he, Bob Karplus, was a little bit appalled at the way that science was taught in my local elementary school. And he volunteered to come into his kids' class and teach some physics lessons. And he went through the lab at Berkeley, and he pulled together all these really cool things, really great things that could provide experiences for young kids, and brought them and thought through the structured activities that he wanted to take the classes through in order to illuminate concepts in physics. And after several weeks of this, he started to realize, or started to observe, that he brought all the stuff in, and he couldn't get the kids to do the activities. As soon as he brought out the materials, they were just playing around with the stuff. And he couldn't get the students to actually go through the steps until they had had some time to explore the materials in an open way. And this was completely dissonant with his worldview about learning, right? I mean, he had this thing that, like many of us have experienced being successful in the school system that, that happens in a very structured way. So that caused him to do some research, some educational research, and to go off to Paris and study with Piaget for a couple of years. And he diverted his career from physics into science education. And he developed sort of a theory, an approach to teaching called the learning cycle. And he had a 3-step learning cycle, and then he added a 4th step, and he published a bunch of papers with different people. And much later, in the early 1990s, a guy named Roger Bybee wrote another learning cycle and documented called the 5E lesson plan that has 5 steps to the learn. So there are many different learning cycles and versions of this. And it's evolved and changed over 4 decades, really, since the mid-60s. So this is one model of how people go through a learning experience. So Bob Karplus decided that, first of all, there needs to be an invitation. There needs to be something that causes the learners to want to go the next step. A question that gets posed, a discrepant event, something about their daily lives that this relates to, but there needs to be something. Some people call it a hook, but something to just engage the learner that he called the invitation. And then once the invitation has taken place, and this could be just a moment, a second, a few seconds, it could be an extended experience, but something that causes the invitation, then you need the messing around time. That you need that he calls exploration. That you need to mess around with the materials or the phenomena and just kind of settle into it and get over figuring out what this does and what this does, and just kind of looks like playing around, looks like wasted time, looks like an unruly classroom where you can't get the kids to do what you want them to do because they have a need that needs to be exhausted before they can go forward. And it's becoming familiar with the phenomenon and the materials, so exploration. And then after an exploration phase, then you can go into concept introduction, or we like to call it concept invention, which puts the sort of the onus back on the learner. If it's concept introduction, it means the teacher is telling. or presenting. Concept invention implies that the kids are coming up with their, having experiences and coming up with their own learning and their own construction of knowledge. So it's here in the concept invention when a lot of the new concepts are introduced and new experiences are happening. And this can be happening in many different ways. You could have concept invention from a lecture, from a read and answer, or from a series of hands-on activities, including Station B, right? Station B could be a place where you have a structured activity that helps you to construct a concept. And then after you've really grappled with the concept and you think you kind of have an understanding for the thing that you're messing around with, then we can go into an application phase, thinking about how that relates to making ice cream, or how it relates to the other station over there. How is this going to help me solve the challenge that got posed over there? So the problem-solving challenge is often an application, not always, but there are many different ways that you can apply what you've learned. And then the part that most often gets left out, that we most often run out of time for, is to sit back for a second and go, okay, what just happened? What did we do? What did you learn? What worked for you? What didn't work for you? Really the metacognitive process of thinking about what it is from this experience that you want to stick, right? What is it that came? We just did 30 things. What's the thing that was really meaningful to you that you don't want to forget before you go home tonight, before you fall asleep, that you still want to have it there? So that sort of reflection about the learning experience. What worked for me, what didn't, what did I learn, what would I do different next time, etc. Needs to take place in a very structured way. Usually does not happen naturally. And then that can lead right back into, after the reflection, sort of a new invitation, a new cycle. We think about this in a variety of different ways. A lesson can have a learning cycle. A unit of study can have a learning cycle that's made up of a bunch of lessons that have learning cycles, right? There can be sort of learning cycles within a bigger learning cycle. We often find, dang it, we missed a step. Did anybody learn anything? Maybe it's okay to miss a step. Sometimes you go invitation, exploration, reflection after the exploration. And then you come back down and do concept. So there's not one pathway. It's not a neat circle like it looks like. You can skip steps, you can loop around. There are many different ways that this can play out. But it just provides a framework, not a script, not a lesson plan, but a framework for thinking and planning instruction. Am I always missing exploration? Do I never do this? Do I always start right away with concept invention because that's what I'm most comfortable with? That's the way I learned when I was at that level in my learning. So I always skip right away to this one. Do I never do application or reflection? I always kind of do a cycle that's like this. So there are a variety of different ways to sort of use it as a tool. So think about all the different experiences that we had today, the 4 stations and the demos that we just did for the content. Where do you think they fit in the cycle? Can you map any of the experiences to places in your little learning cycle as we were going through the last couple hours?
They're all reflecting right now.
Yeah. Yeah, long day, right at the end. But you can see the open-ended activities were mostly exploration, messing around. But if you went to this one last, if you had the open-ended last, some people were saying, whoa, that's where I was doing application. I learned all the concepts, and that helped me to do the open-ended thing and figure out how to learn for myself. So depending on the sequence, one activity could play a different role, depending on where it is in the sequence. So there's not one way to put things together, but it provides a mechanism for sort of thinking about how you're going to put it together in a variety of different settings.
seemed to me like these last 3 activities that we did were really the hook or the invitation for me. Okay. Oh wow. There's this element of surprise. What's going on? I want to learn more. So I don't know.
Yep.
Maybe because of the process of the prior activities, I was back up in my reflection phase. I'm not sure.
Yeah. So depending, I mean, they could play different roles at different points in your own learning process. But yeah, those sometimes teachers often use a discrepant event, something like this, some demo that's like, whoa, a little bit surprising, that is the hook, that starts a whole unit of study, and that you refer back to over and over and over again, like the ice cubes thing. You know, you don't get the answer until 3 weeks later. But like, what was it that was making the blue dye stay at the top and the ice cubes melt faster? And you know, it's something to sort of keep you engaged and keep you thinking. Any other thoughts or reflections about this as a model, as a framework?
Through my experience, I think there's another stage that needs to be added to that. And that's after the reflection, the presentation. When working with middle school kids, when we go out in the field and we learn something, they want to tell somebody about it. And if it has anything to do with marine debris, algae, overuse of natural resources, they always want to say something about it, and rightfully so. So, you know, we create PSAs with information, and then, or have them write something if they're a better writer than they are, you know, than they are using electronic media. Write something to the Maui News or something, and say, hey, this is what we studied in class. This is what we see going on. This is what I'm concerned about, and this is what I want you to do about it. You know, so for a middle schooler especially, that anchors the knowledge, and it gives them a purpose to keep on learning more and more, and it really applies what they learn in the class for that week already. So,
yeah. So yeah, you said it applies. I mean, I think that, and what you're saying is the application can come here, and it can come after the reflection. You can reflect. You could probably have reflection between all the steps, right? I mean, that might be a little cumbersome, but that application to the real world. Okay, so now what are you going to do about it? You learned all this stuff. Knowledge is power. What are you going to do about it? How are you going to use that in some applied way? Any other thoughts? I'm just about to stop, I promise.
I think maybe the one piece missing is the evaluation and assessment. You know, we talk a lot about the learning cycle. Some of my group members said how I was dropping out, cheating here. So as educators, we should have some kind of assessment piece factored in there somewhere. I don't see it up there.
Yeah. Yeah, and they're different. The 5 E's, one of the E's is evaluation that reflects assessment. And we think about that as part of the reflection process. So there's different ways to represent it that foreground and background different ideas, but absolutely.
And one of the other things that you're doing, you notice that this worksheet for the structured activity could also be an embedded assessment for the teacher too, to see how they're doing. So there could be those embedded assessments along the line too. Right.
Yes. Just to bring it, that you know, it's talking about classrooms a lot, but in an informal setting, this idea can be applied too. And maybe it happens more quickly, but you know, the idea that we can go through these stages even with a crowd that's gathered to go for a guided walk or something, so that at each stop you're drawing their attention to something they can observe, they're doing some exploring, they're coming up with some concepts about it, you know. Maybe you ask one question that has them apply it, and then you link it to a bigger idea or something, you know. It's so there's, even in informal settings, you can think in those terms, I think, you know.
Absolutely. And getting back to some of the opening comments about, you know, encountering visitors at Waikiki Aquarium, you may have 90 seconds.
Yeah.
And so, can you go through the whole learning cycle? How are you going to choose to use that 90 seconds? Where is the learner when they come to you? They're probably going through some kind of a learning cycle. You're just not with them the whole time. right? So you have to kind of like figure out as they're walking up, where are they? Did they just come out of an exhibit gallery where they got a bunch of this? Did they just walk in the door and they haven't even gotten this yet? You know, so you can kind of take them, hold their hand to the next step along, and then they're off on their own again. But in different settings, this may be applied in very different ways. Okay, so today in this session, when we did the first writing prompt, I gave you the very first thing I did after lunch was say, write about what you think, what you're thinking about, your beliefs about teaching and learning, and then go talk to a partner about it. That was invitation. The 4 stations were like an exploration of different learning styles. Concept invention was when we talked about those learning styles, and then concept invention related to the concepts that were in this part when we were going through the demonstrations. When I put this slide up and started applying what we had done to the model, that was application, and right now we're in sort of reflection.
And then you're going to do a test.
Yeah, right. Evaluation next, because he wants evaluation.